is Jesper Hongwen. I am the group reporter for Group 2. We did the Rankin cycle last week. So we had 3 main objectives for this lab. It was basically to understand the operation of the Rankin cycle, to measure relevant data, and to also calculate the performance parameters such as efficiency and temperatures. So to your left, this is the apparatus that you'll see in lab for those that are doing the Rankin cycle. Next week, to your right, you'll see a bit of a diagram where from process of 1 to 2 is the pump, where the pump pressurizes the liquid coming from the condenser prior to it going back into the boiler. And 2 to 3 is the boiler system, where the liquid enters the boiler, which is then heated to a superheated state while in the boiler. Then 3 to 4 is where it goes into the turbine, where the steam from the boiler, which has an elevated temperature and pressure, expands through the turbine to produce work, and then it's discharged to the condenser with relatively low pressure. And then from 4 to 1, it goes through the condenser, where the low pressure steam coming out of the turbine is condensed back into liquid water. So some things to keep in mind during the experiment was, we were asked if we knew why the steam admission valve had to be opened before putting water into the boiler, and it's because if you don't release all that steam, all the air inside the boiler won't allow the water to go in. You want to make sure to measure the weight of the propane tank before and after the experiment. When going up to the, I believe it was 110 psi, you wanted to make sure to open the steam emission valve around 100 psi, that's so it has time to stabilize once it gets to that 110. And more pressure would equal more speed, which would equal higher temperature, which also means more steam. And then you'll see later on, but you want to make sure that the RPM does not exceed 3,000. I
just
skipped
skip.
one. Yeah.
I'm sorry, we're having some technical difficulty.
So this is from the data that we got from the DAC system. This, you can see that the temperature in the beginning was a lot lower than as time went on. So that is for the boiler temperature, versus time as it gone on. Next slide.
I'm so sorry, I don't know why this is happening.
It's okay, if anything, you can just go to the main part and just click it.
It's like not responding at all.
This is the free fall versus time. You can go to the fourth one. Oh, cool. That is fine. You can go to okay. You can just leave it. Oh, never mind.
There's some Wi-Fi issues.
This is the turbine inlet and outlet temperature versus the time. As you can see, the inlet temperature of the turbine was a lot higher from beginning to end compared to the exit, and that's just because as time went on, as it was leaving, the temperature from out was a lot less.
Try opening it in the PowerPoint app.
It's okay. You can just leave it that way and then just click it on the side.
Okay. It loads.
How about you download all the presentations?
Okay.
Yeah, you just reuse it. It's fine. It's pretty much. the output voltage versus time. We had to make sure the voltage also didn't exceed like about 11. And then for plot 7, this one you see that the RPM didn't go past 3,000 because there's a coil inside that little, it was inside one of the apparatus parts, but if it went over 3,000 RPM, it would be spinning too fast, which would cause the coil to melt, and we don't want that. In plot 8, this was just the amount of current that was generated as time went by during our experiment. And then values of, well, the next slide would be values I've got from the DAC at that specific time, 1628. Those were all the values that were given to us from the DAC. And the next one is just my calculations. I had hand calculations. I had it on a sticky note. I forgot to put it on there. But as you can see, my efficiency was 48%. I know that's not correct, but I think I probably interpolated some of my data wrong, so my calculations might not have been the best.
Is that it?
Yeah.